Hi guys, in this session we're going to deal with fractional indices. That is, indices which are expressed as fractions. Now this might sound confusing, but you'll find that it's not so confusing when I explain how it all works. So first of all I want to present you with what's called the 8th index law, and it states that a to this particular fractional index, m over n, is equal to the nth root of a, all raised to the power m. And it can also be expressed as the nth root of a to the m. Okay? Now that might seem very confusing, but fear not, I will explain it to you. And I'm going to use an example. The example is 3 raised to the power a half, where half is our fractional index in question. Now if I take 3 to the half and I multiply it by itself, okay, that's 3 to the half times 3 to the half. You know that by the first index law, that would give you 3 to the half plus a half. Remember, we're just adding up the indices. And they are fractional indices, but the process works exactly the same way. So 3 to the half plus a half, come on guys, what's a half plus a half? It's 1, isn't it? So that gets you 3 to the 1, which of course is just good old 3. And that's according to the first index law, as I was saying. But there is another calculation that we can do which gets us to exactly the same result. And that is that the square root of 3 times the square root of 3 equals the square root of 3 all squared, which gets us to 3. Now, if you think about that seeming conundrum, the square root of something multiplied by itself has to get you the something, in this case 3, okay? Now, those results get you 3. Each of them gets you 3, but they each involve something multiplied by itself. Something multiplied by itself. This 3 to the half multiplied by 3 to the half, and also the square root of 3 multiplied by the square root of 3. Now there is only one particular thing which multiplied by itself can get you 3. Okay? These are equivalent computations, and hence I can say they must be the same little gremlin. This 3 to the half must be the same as the square root of 3. Okay guys? Similarly, if you use the same logic, you can show that 3 to the third is the cube root of 3. And if you want to generalise that, you can show that 3 to the 1 over n is the nth root of 3. Or completely generalising, you can say that a to the 1 over n is the nth root of a. So a to the 1 over n is, in fact, the nth root of a. Alright? Now there's one final step here and another leap of logic, which I'll explain to you as we go. Finally, we can look at a to the m over n, not 1 over n, but m over n. And there are two ways of dealing with this, and they are both equivalent. We can firstly look at a to the m over n as a to the 1 over n raised to the power m. Now, you can see that if we used our index laws to multiply out this bracket that I've just created, then that would be a to the m times 1 over n, which is a to the m over n. So that is the same as that. But if I take what's inside the bracket here, that is now, according to our new understanding, that is the nth root of a. So we can say it's the nth root of a raised to the power m. Alright? So that's the first way of interpreting a to the m over n. The second way is that we can just similarly express it as a to the m in the bracket raised to the power 1 over n. Because remember, when you multiply this bracket out, m times 1 over n is m over n, as we have up here, alright? So this one here, we've got a to the m inside the bracket, and we can interpret that as the nth root. If it's raised to the power 1 over n, it is the nth root of what's in the bracket, which happens to be a to the m. So it is the nth root of a to the m. It's also the nth root of a raised to the power m. They are exactly equivalent things, and that is the statement of our 8th index law, which I started with on this screen up here, ladies and gentlemen. Okay? Now enough with all these symbols, let's do some examples to see whether we can really do this, okay? So we've got to evaluate each of the following without using a calculator. So number A, we've got 9 to the half, which we now know is the square root of 9, and the square root of 9 is 3. So that's our answer. Nice and simple. In B, we've got 16 raised to the power 3 over 2. Now, what we can do is we can break that up as 16 to the half, all cubed. Because I know that 16 to the half is the square root of 16. So we have the square root of 16 cubed, okay? And therefore, we know, of course, that the square root of 16 is 4. So we have 4 cubed, which is 64, if you work it out. And that's your answer, guys. Pretty nice, huh? All right, let's do some more. We've got to evaluate or simplify each of the following. Well, they look a bit more complicated, but fear not, we will overcome. Number A today, hooray, we've got m to the 1/5 times m to the 2/5. We just apply our index law number 1, and all we've got to do there is express that as m to the 1/5 plus 2/5. And what's 1/5 plus 2/5, guys? It's 3/5. You know how to add up fractions, don't you? Oh, of course you do. It's m to the 3/5. Isn't that great? See, you can do it. You can do it, guys. Number B, we've got a squared b cubed in brackets all raised to the power 1/6. Well, that would be a squared to the 6th times b cubed to the 6th. And when we multiply the 2 by 1/6, we get 2/6 here, a to the 2/6, and then that'll be times b to the 3/6, all right? And those fractions can simplify by cancelling down. The a would be to the, what would it be? A to the 1/3, and b would be to the half. And that's our answer, guys. Yes? Beautiful. We're going really well. Now, number C. Looks very beastly, doesn't it? But fear not, we will overcome. We will definitely overcome. So we've got x to the 2/3 over y to the 3/4 all raised to the half. Well, simple matter, guys. You just multiply this by this when we're multiplying out the bracket for the x term, and for the y term we do the same thing. All right? No problem. So it's x to the 2/3 times a half over y to the 3/4 times a half. Now, just looking at that, we've got fractions multiplied by each other now. So this one, I can see some cancelling there. The 2 on the top will cancel with the 2 on the bottom, leaving just x to the 1/3. And this one down here, there's no cancelling top to bottom, so it's going to be y to the 3/8. 4 times 2 is 8. And there's our cancellation on the top, and we get that. X to the 3rd over y to the 3/8, and that's our answer. And we're laughing, guys. Here's the remember bit for us to go through before we finish up. Fractional indices are those which are expressed as fractions, of course. Number 2, terms with fractional indices can be written as surds, which we've been doing, using the following identities: that a to the 1 over n is the nth root of a, and a to the m over n, as we worked out earlier, is the nth root of a to the m, or if you like, the nth root of a, all raised to the power m, okay? And lastly, we know that all index laws are applicable to fractional indices. Okay, off you go. Lots of practice for you, and we'll see you soon.